In this section, we are going to discuss different numericals related to two-reaction theory, that is, problems using two-reaction theory phasor diagrams and problems using slip test data. The first problem is a 11 kV three-phase alternator has a direct axis and quadrature axis synchronous reactances of 1 and 0.6 per unit respectively. Compute EMF induced in per unit and actual value, voltage regulation when the alternator delivers rated kVA at 0.8 power factor lagging, 0.8 power factor leading and unity power factor. Also, we need to draw the phasor diagram in each case. Consider the first case, that is 0.8 power factor lagging. Since rated kVA is not given, and let's take this voltage as the line value, base value of the line voltage, and the phase value of the line voltage is obtained as 6350 volt, that is the base value for phase voltage. As rated kVA is not given in the problem, let's solve the problem in per unit basis. Let's take V rated as 1 per unit, that is 1 angle 0 per unit, and rated current is 1 per unit. Since armature resistance is not mentioned in this problem, we can neglect it. We know corresponding to lagging power factor, here the power factor is 0.8, therefore sin phi is equal to 0.6. So corresponding to lagging power factor, internal power factor angle equation is tan inverse V sin phi plus ISQ divided by V cos phi plus I into RA, and the relationship between different angle is psi is equal to phi plus delta. As armature resistance is 0, this equation can be simplified as tan inverse V sin phi plus ISQ divided by V cos phi. Substituting the per unit values of voltage and current as 1 per unit, sin phi is equal to 0.6, SQ is 0.6, XD is 1. So substituting all these values, psi is obtained as 56.3 degree. Then from this relation, that is psi is equal to phi plus delta, we can compute delta as delta is equal to psi minus phi, that is 56 minus angle phi. Phi is obtained from here, that is cos inverse 0.8, and it is obtained as 36.87. Substituting, delta is obtained as 19.43 degree. Then using this delta, we need to resolve armature current into two components. ID is equal to I sin psi. Substituting, we can obtain ID as 0.83 per unit. Then IQ is I cos psi. Substituting, we can obtain IQ as 0.55 per unit. Then we know the expression for E0 as V cos delta plus IQRA plus IDXD. Substituting different values in this equation, we can obtain E0 as 1.775 per unit. We know per unit value is equal to actual value by base value. So from this we can obtain actual value as per unit value into base value. Here this is the induced voltage in per unit that we need to convert into line value and phase value, actual values. So we need to multiply this per unit value with base value in kV, we can obtain actual value of induced EMF in line value. If we are multiplying this voltage in per unit with this base value, we can obtain phase value of induced EMF. So line value of induced EMF is equal to 1.775 into 11 kV. This is the base value corresponding to line. Therefore, line value of induced EMF E0 is obtained as 19.53 kV. Similarly, the phase value of E0 is equal to 1.775 into 6350, and it is obtained as 11.27 kV. Now we need to find out voltage regulation. The second part is we need to find out voltage regulation. We know voltage regulation is equal to E0 minus V by V into 100. Here we can compute this by means of per unit value itself. E0 is 1.775 per unit and V is 1 per unit. We can obtain voltage regulation as 77.5%. Coming to the last section, that is we need to draw the phasor diagram in each case. So corresponding to 0.8 power factor lagging, we can draw the phasor diagram. So here we can take V as reference, and armature current is lagging voltage by power factor angle phi. Then we need to resolve this armature current into a component which is coming in phase with E0 and component of current which is coming quadrature with E0. So let's resolve this armature current into a horizontal component which is coming in phase with E0 and a vertical component which is coming in quadrature with E0. Like this. We will mark this angle, that is angle between IQ and I, as psi later after completing the phasor diagram. Then we need to consider different drops. that is I into RA, IQ into SQ, ID into XD. As RA is 0, I into RA drop won't be there in this case. So let's consider IQ RA drop first. So from the tip of V phasor, we need to draw a phasor which is leading IQ by 90 degree, that is IQ SQ phasor. Then we need to consider ID XD phasor which is leading ID by 90 degree. This completes the phasor diagram corresponding to 0.8 power factor lagging. Angle between E0 and I is psi, and angle between E0 and V is load angle delta. Please mark different parameters which we got from this problem in this phasor diagram. Now coming to the second case, that is 0.8 power factor leading. The phase voltage is same, that is 6350 volt, that is taken as 1 per unit. Rated current is taken as 1 per unit. RA is equal to 0. As cos phi is 0.8, sin phi is 0.6. Corresponding to leading power factor case, internal power factor angle psi can be obtained by means of this equation, that is tan inverse V sin phi minus ISQ divided by V cos phi plus I into RA. And the relationship between different angles are psi is equal to phi minus delta. As armature resistance is 0, we can simplify this equation as psi is equal to tan inverse V sin phi minus ISQ divided by V cos phi. Substituting different values, we can obtain internal power factor angle psi as 0 degree. And from this relation, we can find out delta as phi minus psi, which is coming as 36.87 degree. Then using this delta, we can find out ID and IQ. ID is equal to I sin psi, which is coming as 0 per unit. Then IQ is equal to I cos psi, which is coming as 1 per unit, that is armature current itself. Now we can compute E0, which is equal to V cos delta plus IQRA minus IDXD. This part is 0 and this part is already 0. Why? Because RA is 0. Therefore, E0 is equal to V cos delta, that is 1 into cos 36.87, which is coming as 0.8 per unit. We know per unit is equal to actual value by base value, and actual value is equal to per unit value into base value. Therefore, line value of E0 is equal to 0.8 into the base value, that is 11 kV. Actual value of line value of E0 is obtained as 8.8 kV. Similarly, actual value of phase value of E0 is obtained as 5.08 kV. Now, voltage regulation is equal to E0 minus V by V. It is coming as minus 20%. Now, let's consider the phasor diagram corresponding to 0.8 power factor leading. Let V be the reference phasor. Armature current I is leading voltage by power factor angle phi. Then we need to resolve this armature current into two components, that is in phase component, which is in phase with induced EMF E0. In this case, from this problem it is found that ID is equal to 0 and IQ is equal to 1 per unit, that is same as the armature current, and IQ is coming in phase with E0. Angle between E0 and I is 0. Then we need to consider various drops. Here only one drop is available, that is IQ SQ. IQ SQ drop is drawn from the tip of V phasor, which is leading IQ by 90 degree. So this completes the phasor diagram corresponding to this situation. Here it is to be noted that psi is 0, that is angle between E0 and I is 0, and angle between E0 and V is delta. Please mark different parameters in this phasor diagram. Now coming to the unity power factor case, this is the phase voltage, that is 6350 volt. V rated is taken as 1 per unit. Rated current is 1 per unit. Armature resistance is neglected. As power factor is 1, sin phi is 0. We know the expression for psi under unity power factor as tan inverse ISQ divided by V plus I into RA. And the angle relations are psi is equal to delta. As RA is 0, this expression will reduce to tan inverse ISQ divided by V. Substituting different parameters, we can obtain psi as 30.96 degree, which is equal to delta. Now we can compute ID and IQ. ID is equal to I sin psi, which is obtained as 0.51 per unit, and IQ is obtained as 0.86 per unit. Then we know the equation for E0 as V cos delta plus IQ RA plus ID XD. Substituting, E0 is obtained as 1.715 per unit, and actual value of line value of E0 is obtained as 18.87 kV, and phase value of E0 is obtained as 10.89 kV. Then voltage regulation is obtained as 71.5%. Coming to the phasor diagram corresponding to unity power factor case, V and I are in phase. We need to resolve armature current into a component which is coming in phase with E0, that is IQ, and component of current which is coming quadrature with E0, that is ID. Then we need to consider various drop, that is IQ-SQ drop and ID-XD drop. IQ-SQ drop is drawn from the tip of terminal voltage which is leading IQ by 90 degree. Then ID-XD drop is drawn which is leading ID by 90 degree. This completes the phasor diagram corresponding to unity power factor case. Angle between E0 and V is delta, which is exactly same as psi. Please mark different parameters which we got from the problem in this phasor diagram. Coming to the second problem, a 30 kVA 3-phase 50 Hz alternator supplies full load at 0.8 power factor lagging, 0.8 power factor leading at a terminal voltage of 400 volt. The per phase value of direct and quadrature axis reactances are 0.82 and 0.51 ohm respectively. We need to compute the line value of induced EMF and full load voltage regulation. Coming to the solution, here the line value of the voltage is given as 400 volt and full load output is 300 kVA. So from this line value and this kVA rating, we can calculate the rated current, and rated current is obtained as 433 ampere. And after converting this line value into phase value, the phase value is obtained as 231 volt. And here XD is given as 0.82 ohm and SQ is given as 0.51 ohm. Now let's consider the first case, that is 0.8 power factor lagging. As cos phi is 0.8, sin phi is equal to 0.6. Corresponding to lagging power factor, psi is equal to tan inverse V sin phi plus ISQ divided by V cos phi plus I into Ra, and angle relations are psi is equal to phi plus delta. As armature resistance is 0, this equation is reduced into this, that is tan inverse V sin phi plus ISQ divided by V cos phi. Substituting different values in this equation, we can obtain psi as 62.79 degree. From these angle relations, we can find out delta is psi minus phi and delta is obtained as 25.92 degree. Then we can resolve armature current into two components, that is ID and IQ. ID is equal to I sin psi, which is found to be 385.1 ampere, and IQ is obtained as 198 ampere. Then substituting these values in this equation for induced EMF is obtained as 523.5 volt. We need to convert this phase value into line value. The line value of E0 is equal to root 3 into 523.5, which is coming as 906.8 volt. Next, we need to compute voltage regulation. Voltage regulation we can find out by means of line value or phase value. Voltage regulation is equal to E0 minus V by V. If we are considering line value, we need to consider all this voltage by means of line value. If we are substituting the phase value, we need to substitute all these values with the phase value. We can obtain the same answer. And voltage regulation is obtained as 126.7%. Then coming to 0.8 power factor leading case, line value is 400 volt, full load output is 300 kVA, rated current is coming for 33 ampere, armature resistance is 0, V phase is coming 231 volt, XD is 0.82 ohm and SQ is 0.51 ohm. As cos phi is 0.8, sin phi is 0.6. Corresponding to leading power factor case, psi is equal to tan inverse. Here it becomes negative. And angle relation is psi is equal to phi minus delta. As armature resistance is 0, psi is coming as tan inverse V sin phi minus ISQ divided by V cos phi. Substituting different values in this equation, psi is obtained as minus 23.99 degree. And from this angle relationship, we can find out delta. Delta is equal to phi minus psi, which is obtained as 60.86 degree. Now we need to resolve armature current into two components, that is ID and IQ. ID is equal to I sin psi, which is coming as minus 176.03 ampere, and IQ is coming as 395.60 ampere. We know the induced EMF is V cos delta plus IQR minus ID XD. Substituting these parameters in this equation, we can obtain E0 as 256.83 volt. Now the line value of E0 is root 3 into 256.83, which is coming as 444 volt. Voltage regulation is E0 minus V by V into 100, and it is coming as 11.21%. Coming to third problem, a 30 kVA 3-phase 50 Hz alternator supplies full load at 0.8 power factor leading at a terminal voltage of 400 volt. The per phase value of direct and quadrature axis reactances are 0.82 ohm and 0.5 ohm respectively. We need to calculate load angle and line value of induced EMF. Also we need to obtain voltage regulation. Coming to solution, here line value of the voltage is 400 volt and full load output is 30 kVA. Rated current is calculated from line value and full load output as 433.3 ampere and phase voltage is 231 volt. Armature resistance is neglected and XD is given as 0.82 ohm and XQ is given as 0.51 ohm. As cos phi is 0.8, sin phi is 0.6. Corresponding to leading power factor case, this is the expression for psi, tan inverse V sin phi minus ISQ divided by V cos phi plus I into RA, and the angular relation is psi is equal to phi minus delta. Substituting different parameters in this equation, we can obtain psi as 32.23 degree and delta is obtained from this relation as 4.64 degree. Now ID is equal to I sin psi, which is coming as 23.09 ampere, and there is no need of calculating IQ as IQ RA is coming 0 as RA is equal to 0. Now E0 is equal to V cos delta minus ID XD. Substituting different parameters, E0 is obtained as 211.3 volt. Line value of induced EMF E0 is root 3 into 211.3, which is coming as 365.98 volt, and voltage regulation is obtained as minus 8.5%. Coming to the fourth problem, this problem is related to slip test. The oscillogram for slip test for a star connected 3-phase 25 kVA 220 volt 50 Hz 1000 rpm alternator shows the following test results, that is RMS value. Maximum value of voltage is 200 volt, minimum line current is 55 ampere, minimum line voltage is 180 volt, maximum line current is 90 ampere. Here we need to calculate the actual and per unit value of direct axis and quadrature axis reactances. The given parameters are Vmax is equal to 200 volt, Vmin is equal to 180 volt, Imin is equal to 55 ampere, Imax is equal to 90 ampere. Here the question not mentioning about armature resistance, therefore we can take Ra as 0. As armature resistance is 0, the direct axis synchronous impedance is equal to direct axis synchronous reactance, and it can be calculated using this equation Vmax by root 3 into I minimum. Substituting, we can obtain the actual value of direct axis reactance as 2.099 ohm. Then quadrature axis synchronous impedance, which is equal to quadrature axis synchronous reactance SQ, can be calculated by means of this equation, that is V mean by root 3 into Imax. Substituting different values, we can obtain SQ as 1.155 ohm. Now we need to convert XD and SQ into per unit value. So per unit value is equal to actual value by base value. Here the base value of the voltage is 220 volt. Therefore we can convert these voltages in per unit. So per unit value of Vmax is equal to 200 by 220 and per unit value of Vmin is equal to 180 divided by 220. Correspondingly, Vmax is obtained as 0.909 per unit and V minimum is obtained as 0.818 per unit. Now we need to calculate base value of current using this power rating and voltage. So rated current is obtained as 65.6 ampere. Now we need to convert I min and I maximum into per unit. Now I max in per unit is 90 by 65.6, that is 1.37 per unit. I min in per unit is obtained as 0.838 per unit. Now we can compute XD. XD is equal to Vmax in per unit by I min in per unit, that is obtained as 1.08 per unit. Similarly, XQ in per unit is equal to Vmin in per unit by Imax in per unit, which is obtained as 0.597 per unit. Coming to the fifth problem, a salient pole alternator has direct axis and quadrature axis reactances of 80% and 40% respectively. We need to determine its regulation if the machine delivers full load at rated terminal voltage and 0.8 power factor lagging. Full load current and rated terminal voltage may be considered as 100%. In this problem, direct axis reactance is 0.8 per unit, quadrature axis reactance is 0.4 per unit. Armature resistance is not given, so we can neglect it. And the rated voltage and rated kV is not given. We need to proceed with per unit calculation. So V rated is taken as 100% means that is 1 per unit. Full load current is taken as 100% means that is 1 per unit. As cos phi is 0.8, sin phi is 0.6 and phi is obtained as cos inverse 0.8 which is coming as 36.87 degree. Corresponding to lagging power factor case, this is the expression for psi and this is the angle relation. As armature resistance is 0, psi is equal to tan inverse V sin phi plus Isq divided by V cos phi. Substituting different values, we can obtain psi as 51.34 degree. And from this angle relation, we can compute delta as psi minus phi and it is obtained as 14.47 degree. Then we can resolve armature current into two components, that is ID, which is equal to I sin psi, which is coming as 0.78 per unit, and IQ is coming as 0.6246 per unit. Then by means of these parameters, we can compute E0. E0 is equal to V cos delta plus IQ RA plus IDXD. Substituting, we can obtain E0 as 1.592 per unit. We know voltage regulation is equal to E0 minus V by V into 100. Substituting, we can obtain voltage regulation as 59.2%. Coming to the sixth problem, a salient pole alternator has direct and quadrature axis reactances of 80% and 60% respectively. It is having resistance of 10%. We need to determine its regulation if the generator delivers full load at rated terminal voltage and 0.8 power factor lagging, and second case 3/4 the full load and 0.8 power factor lagging. Coming to the solution, XT is given as 0.8 per unit, SQ is given as 0.6 per unit, RA is 0.1 per unit. Here also, as rated kVA and rated voltage is not given, we need to proceed with per unit calculation. Let V rated is 1 per unit, and considering the first case, that is full load, that is rated current is 1 per unit. As cos phi is 0.8, sin phi is 0.6 and phi is obtained as 36.87 degree. Then corresponding to lagging power factor case, this is the expression for internal power factor angle and this is the angular relations. And substituting different values in this expression, we can obtain psi as 53.13 degree, and from this angle relations we can compute delta and it is obtained as 16.26 degree. Then we can resolve armature current into two components, that is ID and IQ. ID is obtained as 0.8 per unit and IQ is obtained as 0.6 per unit. Substituting all these parameters in the expression for induced EMF is obtained as 1.66 per unit. Then voltage regulation is equal to E0 minus V by V into 100 and it is obtained as 66%. Coming to the second case, that is 3/4 the full load, that means current under that situation is 0.75 per unit. So corresponding to this case, angle psi is obtained as 50.19 degree and delta is obtained as 13.32 degree. Computing ID is obtained as 0.576 and IQ is obtained as 0.48 per unit. Substituting different parameters in the equation of E0, we can obtain E0 as 1.482 per unit, and voltage regulation is E0 minus V by V into 100 and it is obtained as 48.2%.